Hi, in this lecture I'd like to show you a demo project that was created with KiCad and also where you can find other projects of really interesting PCBs that were also created with KiCad. This is simply an overview of some of the things you can do with KiCad. In this lecture, I try to not concentrate too much on the details of the things that I'm about to show you. It's meant just to give you an overview. As I said, everything that I'm about to show you will be going into a lot more detail in the upcoming projects. So for now, just sit back and relax and see what you can do with KiCad. If you followed the instructions in the previous few lectures that were about installing KiCad on your computer, whether Windows, Linux, or the Mac, there's a good chance that you have already downloaded and installed the folder that contains the demo projects. And here is mine. If, however, you used an installation archive that did not include the demos, and sometimes that is possible, some of the installation archives remove a few components just to keep the installation file smaller and the download file smaller, then you can still get to the demo projects manually. So the way to do that is to go to the KiCad website, go to downloads, then under all platforms, click on source code. And here you'll see a link to the GitLab main repository. In the GitLab main repository, let's go to the source code, KiCad. This is where you'll be starting from, and you'll see the demos directory right there. You can download the whole lot by clicking on this download button. Probably you want to select zip, and then you download the whole repository. And inside demos, where is it? Demos, there you go. Right here, you'll get through all of these files, all of these directories containing demo projects. Another interesting place for projects made with KiCad is this page here. So you can discover made with KiCad, and there's a lot of very interesting projects of all sorts of complexity and shapes and so on. So have a look at this and see if anything strikes your fancy, and you'll be able to download it. In general, the process is go to the Made with KiCad page, find a project that you like, let's say the CSC Arduino version 4. That will take you to the website for that project, and then you'll find a way to click your way through to the repository. So for the CSC Arduino, there's a GitHub repository, and that will take you to the repository that you can download. It contains the KiCad files. Now, just one thing to be careful about is that some of those projects are made with an earlier version of KiCad, not KiCad 6. So you may need to fix a few dependencies, such as symbols, for example, that were present in a KiCad 5 library, but not in a KiCad 6. But if you don't want to have to deal with any of that, just go and have a look at the demos that ship with KiCad 6, like I'm about to show you. So here's the KiCad 6 list of demo projects, and there's a bunch of very interesting projects here, but I thought that the PIC programmer project is a very good one to have a look at as a first example project, because it is neither too complicated, neither too simple. It gives you a very good overview of everything that you can do with KiCad. So you can see that inside its project directory, you've got a bunch of files, but the ones that are more important for our purposes right now are these. So we've got, actually, I'll select that one as well. So we've got the KiCad_pro file, which is the main project file for this KiCad project. And we've got KiCad_sch. We've got two of those because we actually have 2 pages that consist of the schematic of this project. And then we have the KiCad_PCB, which is the layout. So it's a single project, so a single layout for this project. You can independently double click on a PCB or the schematic, and that will bring up the appropriate app to display this file. So I double clicked on KiCad_PCB, and that brought up PCBnew, which allows me to play around with the layout independently of the rest of the project. You can do the same thing with the schematics. So here is the main schematic sheet for the project. You can do the same thing with the second PIC sockets. So here's a second page for the schematic. You can jump between one and the other through the navigator. Not in this case though, because I have brought up Eeschema independently of the project. So Eeschema doesn't really know that there is a second page involved. So this is an okay way to do things in KiCad and treat each app in KiCad as an independent app, and it allows you to have a quick look inside a project if you're looking for something specific. I'm going to close both programs and then double click on the KiCad_Pro file, and that will bring up the KiCad project app. Now notice that it says here KiCad 5.99 instead of KiCad 6, and that's because for recording this particular lecture, I'm using a early release or early nightly build of KiCad 6. And at the moment I'm recording this version is designated as KiCad 5.99, but just beware, this is really just an early release of KiCad 6. So everything that I'm going to show you is going to look very similar to you, assuming that you're using a release version of KiCad 6. So from here, I can now bring up the schematic editor or the PCB editor. And I can also jump between these editors without having to use the project window. So I can jump into PCBnew from Eeschema just by clicking on this button, and then back into Eeschema from PCBnew. So back and forth, these two applications are now intertwined and connected with each other. I can also jump between sheets. So I showed you earlier, you can see here, just move things around. I can get back to my file browser. So you can see that this project contains two schematic files. I can now navigate through those two schematic files using the navigator. I can go into the sockets sheet and then back into the main sheet, the root sheet. Now in many cases, you'll be able to use a single sheet for your PCB, but if things get a bit more complicated, you need a bit more space, or you need to compartmentalize your design, and you can use more than one sheet. I'll be showing you how to do this in one of the later projects. Now let's have a quick look at what is happening in Eeschema. So you can see a lot of familiar elements here. Hopefully you can see things such as resistors. Double click on a resistor and that will give you the symbol properties. There's a reference. You can manually create this reference or assign a reference to a symbol, or you can get KiCad to automatically assign references. You can set a value. You can set a footprint as well. So in this case, we have assigned this particular footprint to the resistor. It is a through-hole component with these dimensions, and you could have assigned any of the other options, of course. And as I said in a previous lecture, it is possible to have a symbol in KiCad that can be connected to any number of compatible footprints. And down here, you also notice that there is a link to a library file, or a link to a file, I should say, that contains instructions on how this particular symbol, it happens now to be a resistor, can be simulated in SPICE. So you can see that there's many other symbols that also have a similar SPICE model file. This is an amplifier, for example, and it's got its own SPICE model so that we can simulate this circuit if needed. Other things that happen here, let's have a look. This is interesting. We've got a net name, so I just moved it up and disconnected it from its actual net. So we've got a wire, but normally wires in a KiCad schematic are given automatic names by KiCad itself. If you want to name a particular wire with a name that you choose, like this, PC data out, then you can just use a label like this. It's a label that we can pick up from the tool bar on the right. And that label, we assign it to a wire. And now this wire has got a name. And very often it is very useful to have a name in wires. It makes it easy to see them, for example, in the PCB layout right here. So let's check this out. In the schematic, I'm going to click on this component. I'll put the window for the Eeschema application and the Pcbnew application side by side, so you can kind of see both of them at the same time. Just give it a bit more space. So I'm going to click on this, just like I can click on any other symbol, and you can see that KiCad will show me this component in Pcbnew. So back to the DB9 connector, I've zoomed into it, and I notice that I've got this net. It's a named net. It goes to pin 4. Let's follow this pin 4 in Pcbnew. So here is pin 4. Yep, so here's pin 4. Zoom in, pin 4. You can see that pin 1 of R3, which is this resistor right here, has got a name, PC data out. And that is the same name as pin 1 of resistor R4, which is this resistor here. So you can see that this information carries through from Eeschema to Pcbnew, and it makes it easy to find things back and forth. Another thing that you can see here in Pcbnew while we are at it is you go to the appearance pane on the right side toolbar, click on nets, and you can see that the net for PC data out also appears right here. You can change its color, you can make it highlight, etc. I'm going to be showing you all of this in subsequent lectures later on in this course. A couple of other things that I'd like to show you here before we move on to have a closer look at Pcbnew is the fact that you can drop components, or symbols I should say, by choosing one of many different symbols in the libraries that come with KiCad. And if you can't find a symbol that you need to use in your schematic, then you can search for it on the internet, and then you can go to the symbol library management tool, and you can add it into your project or into your global libraries. So KiCad ships with a bunch of libraries that are quite comprehensive. Most likely you'll be able to find what you need in here, but if you can't, this is extendable. You'll be able to find what you're looking for on the internet. I'm going to show you places that are really good and contain a lot of third-party symbols and footprints, but you can also create your own symbols and footprints, and I'll be showing you that as well. There's a lot more I can talk about in here, but I'm going to leave it as it is for now. I don't want to overwhelm you. Just one last thing is to show you how the electrical rules checker works. Once you're finished with designing your schematic, you can just bring up the ERC window or ERC tool, click on Run ERC, and then we'll go around and make sure that everything is good and there's no errors. And once there are no errors, you can move on to the Pcbnew tool and start with the layout process. So Pcbnew is really a drawing tool. It allows you to take footprints and move them around, place them, and then wire them, define the borders of your PCB and put in any other elements such as, say, text, informational elements, footprints that allow you to implement things such as mounting holes and things of that sort. And with all that, then you can also use a very useful and fancy 3D viewer, so you can take a look at what your PCB is going to look like in real life eventually. So you can see that there is an element here of connecting a footprint with its 3D model. So in this case, I've got a socket, for example. Just pan over this side. There's a socket. This socket belongs to, Just going to put this away for now. This socket belongs to this footprint right here. If I double click on this footprint, have a look at 3D models, you'll see that there is an association between a 3D model and this footprint. And of course, you can change the sockets, or you can change the 3D models and assign any 3D model that you perhaps create or found on the internet to a particular footprint. You can change its characteristics, how it sits on the footprint, and so on. I'm going to be showing you all this later again. This, as I said, is a drawing tool. So pretty much all of the tools that you see here allow you to create better printed circuit board drawings. So there's a selection filter down here, for example. I can click on that and then select what kind of element out of this design layout I want to use. So for example, let's say that I want to be able to click only on tracks, which is very useful for very busy layouts like this, for example. So I've got a resistor which is overlapping with a couple of tracks. But let's say I want to do something with this particular track and I want to select the resistor. I've selected tracks in the selection filter. So now only the track is selectable, and I can do things such as move it or reshape it or do something else that needs to be done with it. I can also use, say, the tools on the left side to allow me to change the way that some of these elements are depicted. So for example, here I've got this blue copper fill. The blue color tells me that it is created in the bottom layer, but with it enabled, it kind of hides all of the detail of other elements. So I want to make this layout a little bit less busy. So I can just click on this button here and then hide the fill and just depict the existence of a copper fill with this thin line along its edges. It makes the whole thing more readable. It's just an example of the tools that PCBnew gives you to draw this layout. Another thing that I'd like to show you is how these tools work together. So for example, I've got the 3D viewer here. I can select, say, this P2 footprint. Oops, I need to enable footprint selection. So I can select this footprint like that, then go to the 3D viewer and you can see that it's highlighted in green so that I can see how this particular footprint looks in the 3D rendering. Let's do one more. Let's take U1 and there is my U1. Let's go for an LED this time. Here's the LED, D12, and that is highlighted right there. So I can see it stands out. I can do something similar between Eeschema and PCBnew. So here is Eeschema. I can click on this transistor and you can see it's now highlighted. So it will automatically move the PCBnew sheet to the location that the footprint of the symbol that I just clicked on exists. So let's do another interesting example. So this box represents the second sheet of my schematic design. I will double click on it and go to this second sheet, or I can just use the navigator and just click on PIC sockets page 2. Now I'm going to click on P2. And there you go. There is P2 and there is P3 right here. So Eeschema and PCBnew communicate in real time, just like the 3D viewer with PCBnew also talk to each other as I'm working live. Here's the capacitor that I've just chosen. All right, so I'm going to stop my demonstration here of the PIC programmer project as an indicative project of something that you can do in KiCad. Gives you an idea of the capabilities of this application. Also, you had a look at some of its components. As I said earlier, KiCad is not a single application. It's really a collection of apps. The objective of these apps is to help you create awesome PCBs. So this concludes this section in this course. In the next section, which is section 3, I'm going to talk a little bit about the differences between KiCad 5 and KiCad 6, just in case you have been using KiCad 5 in the past and you are now getting into KiCad 6. And I'm also going to show you how to import a KiCad 5 project. And then we'll have a look at the various KiCad applications, such as the KiCad Project Manager and PCBnew, Eeschema, the PCB editor. I'm going to give you a more rounded overview of all of the applications in here that make up the KiCad application. All right, let's move on when you're ready.